Hi everyone, welcome to our support live stream. I'm joined by Michael Noland, Senior Engine Programmer, and Zach Parrish,
Hey.
DevRel Tech Artist. I'll be your mod today. My name is Sean. I'm
You don't even know who you
Developer
are.
Support Manager. There we go.
This is just Sean.
We'll be covering Paper 2D in 4.6. Please submit your questions in the Twitch channel. I'll be monitoring those and sharing those with Zach, who will be presenting.
I'm trying not to table flip right now. You blew that intro
I'm sorry,
so badly. No, I mean, the whole vibe is just wrecked now. So, hey, everyone. Today we're going to be talking about Paper 2D, best practices, working with the system, actually doing fun stuff. Hopefully, if you're watching this live stream, you're at least familiar with the YouTube videos over Paper 2D, which is kind of an intro. What we did in those videos is we took the Paper 2D side-scrolling template and we rebuilt it from just the textures. What I've got here in Unreal is a game that I put together a little while back. I think I started this while I was at Gamescom. I was working the booth, and I was kind of bored, and I had a drawing tablet and a laptop. Here, I'll just make everything nice and big. So I've got a little 2D character. He runs and moves around kind of a lot like the guy from the template, but he can do some other stuff too, like he can sneak around. And he can shoot fireballs because I felt like if he couldn't shoot fireballs, the game really wouldn't be complete. And then we added some other fun stuff too. So he can do the little Spider-Man looking jump, and he can do little wall kicks. And what I wanted to do was kind of talk a little bit about how this system came together, because the Paper 2D aspect of things, the way the plugin itself works, is actually fairly straightforward, right? You're going to bring in your 2D texture, you're going to split it up into some sprites, make that into some flipbooks. But then what do you do from there? And really, it's up to you, but there is some work to be done. So what I wanted to kind of start off with here is just walk you through some parts of this this project. Also, I want to mention that this project is something that I'm still kind of cleaning up, and here within the coming days, I'm going to be putting this up on the Learn tab for everybody to have a look at, so that you'll be able to take this apart. I just have to remove some of the used paper cups and empty beer cans that are lying around inside the project. So one of the things that is important to keep in mind about Paper 2D is that it doesn't currently work with our existing animation blueprint system. So you're not going to create a Paper 2D character and just plug it right into animation blueprints. So what I've done here to make this character have all of these run around and play behaviors is I've built a state machine here inside of Blueprint. So I just wanted to kind of give a quick run through about how this works. So we have a custom event called Update Animation, which is doing a couple of quick checks. I mean, we want to make sure the character's not spawning because we're doing some fancy things with spawning. You might have seen the pencil draw him in, and I'll talk more about that a little bit later. We want to make sure that if the character is falling, that we're taking that into account. We're storing up his speed because we're going to need that as well to make sure we know whether or not he's moving. And then we made a custom function, which is really just a great big state machine. And it's important to keep in mind the type of data that this is pulling in. So we're storing how fast the character is moving, which you saw we just grabbed, whether or not he's crouched, whether or not he's jumping, falling, firing, spawning, all kinds of stuff. There's even one called blank, and honestly, I don't remember what that was for. So once we have all that, we can step down into the function. And the idea here, as any state machine is going to go, is really we just start with the data we have on hand. And because of the way I like to work within functions, I made local versions of all of those incoming variables. If you don't yet work with local variables inside of functions, I can't recommend highly enough that you get used to using them. They make it a lot easier to play around with the data that you bring into any given function. Now, once we've got all of those stored in local versions, we've got a bunch of if-else checks to see what the player's doing. And you can see they're named accordingly. So check and see if we're dying. And that's just a collapse graph. So if I jump inside this, we just say, hey, is the character dying, yes or no? And if I jump back out from there, you can see if we are dying, then we have our true, and we set an enum, which consists of all of our states. Now, if you're totally new to the whole world of enumerations, you can create these inside of your content browser. So here I've got an animation states enumeration, and you can see what it includes. So we've got things like idling, running, crouching, crawling, jumping. All it is a list of named states. That's it. So what we're doing here is we check and see what the player's actually doing. Are they dying? Is he being hurt by something? Is he running? Is he crawling? And then based on whether we find those to be true or false, we either set that state to be true, basically say, all right, we have decided that he is crawling, so we set his state to crawling. If he's not, check the next thing. Was he jumping, yes or no? Once we've collected all of that data, once we know which of these states he's actually in, then we have our final part to the state machine, and this is where we essentially just use that state in a select node to figure out which animation flipbook to play. So here are all of our different animations. We have one for idle, running, crouching, and so forth. So if I grab, let's grab the crawling one, for instance. If we jump over here. This is that part where Michael could be filling in the space with something, but he's not, which,
I'm watching you flounder. It's okay.
That's totally cool. So here's his crawling animation, as you can see. I totally mocapped that, by the way. So let me jump back over to our blueprint. So once we have that, we simply set the output flipbook, and then that's how we know what the next animation is that we're going to play. So if we go all the way back out to the outside of the state machine, this is all we do. We take our target sprite, which is the sprite for our main character, and we're just setting what flipbook is applied to it. So this is kind of an interesting technique that you don't really see. You see, I guess, in a very, very small scale within the animation template, or sorry, in the template for Paper 2D. I think we're just selecting between idle and running, and that was it. So this was something that has a lot more going on. Now the question then becomes, if you're totally new to this, well, where do you get all of these other Booleans? How do you know if he's being hurt? And really, that's where the rest of your blueprint graph is going to come into play. So for instance, if I'm just kind of moving around through this, so we've got all of our different controls. These are really almost exactly the same controls that exist in the template, because again, our character really just runs left and right. We have a special input for jumping, and then if we are not falling, actually we had to be kind of clever here. We had to say, if he's not falling, play the jump animation, because when you play the game, let me show you this real quick. If we hit play, notice that he kind of has a little jump animation. He leaves one leg kind of dangling for just a second, and then he goes into his falling animation. And we needed a way for that flipbook, that jump flipbook, to play only once. So what we did is the moment we jump, we check and say, are you falling? And if you're not falling, then play the jump animation. And then as soon as he switches over to falling, then we check and see if he should be wall jumping. And it's all handled kind of in his states. Actually, let me here you go. Here's the jump animation event. So the moment we detect that he needs to jump, we say, all right, cool. His state is now jumping. We say he is jumping. And I literally had to hard code this because at the time, Michael, this is where the camera clicks back to me staring at Michael awkwardly. At the time, there was no way to see how long a flipbook was. I don't know if there is yet.
Yeah, there is.
Awesome. So when I put this together, there wasn't. So what we did instead is we did a little bit of math. We said, here's the frames per second by how long the thing plays. So now we know how long to wait. So basically, this delay works out to be just exactly as long as the jump animation is when it plays once. So we set, we are jumping, we wait until that animation is done playing, and then we say, we're no longer jumping, but because his state will now be falling, he goes into his falling animation instead. So it's a lot of kind of jumping back around, kind of flipping through animations, which I'm sorry, that was horrible, what I just said. Now, I guess the only other thing that was a little difficult to really sort of figure out, having never done it before, was really handling how his capsule changes shape when he crouches. For example, if let's just close this, I'll reopen it if I need it. I hit play, and then, let's go full screen. And I hit the tilde key to bring up the console. We'll do show collision, and now you can see his little collision capsule, right? So when he jumps, I wanted his collision capsule to get smaller, and when he crouched, I wanted that to happen as well. And there's actually a special way to handle this with characters, or at least at the time this was assembled, there was anyway. There is a property called crouch maintains base location. And that is tucked away inside your character movement controller. So let's see if I go
Show inherited variables.
Thank you. The screen's so far away. So actually, it's probably easier if I go over to components first. So go over to character movement, and then just search for crouch. So let's see. They might have changed the name of it. Well, I'm not even seeing it anymore.
Is it on the movement component or is it on the character itself?
I thought it was on the movement component. Well, hang on. Let me just look back at my graph. No, it is on the character movement component. So there is a property in there called, it might, here's the catch to it. You can't actually check this manually. You can't work with this.
So it's only in the graph.
It's only in the graph. Now, a long time ago in a galaxy far, far away, depending on which version you were using, you could actually see this checkbox, but it was grayed out, and you can't actually change it. You can't check it inside the property list. But I knew it was something that I needed to change. So after working with it, it's a property that has to change dynamically. You can only change it at runtime. So what I end up having to do is say, if we are falling, then we need to adjust this property, and if we're not falling, we essentially need to switch it back, which is what this whole section of the graph is all about. The way this works is it tells the capsule that it needs to scale from its own base. So I'm talking with my hands, so it's one of those fun things. But so the idea is that when your character capsule squashes down, instead of squashing toward its center, it's going to squash down toward its base. If you don't do this, the problem is when the character lands, so he jumps up in the air, his capsule gets smaller, and then he would land, and his capsule would extend
Shoot
again.
back through the floor.
And it'd go down through the floor, and he would get stuck, and horrible things would happen, and the game became unplayable, and people flipped the table, and there was much gnashing of teeth. So we discovered this property, or we, being I, having never done this before, discovered this property that allows you to scale from the base instead. The trick is, though, you had to turn it on when he goes airborne, and then turn it back off after he lands. So there's kind of a little bit of toggling going on there. Definitely worth checking out when we get this up in the Learn tab, which again will be coming in the next couple of days. The other really fun thing to set up, I think this is probably the most fun I had in the whole part of the project, was figuring out the wall jumping mechanic, because that was something I wanted really early on. I've always loved wall jumping. I think the first time I ever saw it in a game was the original NES Batman. So Batman would run and he could like jump off a wall and just continue going up. And of course it's been done in like Mario 64 and a million other games since. Now the way we're doing this is, and I think there's even an apology in the comments that it's kind of messy. And I typed the word maths to make all my British friends happy. So essentially what this little red box worth of nodes is doing is it's creating a second capsule that goes outside the boundary of the base collision capsule for the character. So it's kind of like an extended radius. And if there is another object, specifically like a wall within that radius, then we know we're up against a wall and we know we should be doing a wall kick. It's like two things you have to check for. One, you have to say, are you airborne? And two, are you up against a wall? And if you are, it's time to wall kick. So there's basically all of this is how we came up with the math for drawing that capsule. And then we draw the capsule. So I can show you that real quick. Let's take the debug type and we'll set it to for duration. And we'll compile. So now, actually, I'll close that again. And let me hit F11. So now as we run, if I find the great big wall over here, boom. Every time I hit jump in midair, it does this little trace. So it's trying to do that capsule trace, and it's not finding anything right now. And I don't know how well that is, how easy that picks up on the screen. It looks a lot better across the room. But if it finds something, you see you get a green capsule, and then it fires off the rest of your equation, and you get a nice little wall kick. Now, knowing that, let's jump back over to our blueprint.
So real quick, one other neat trick for working with a single monitor and doing blueprints and testing like this is switching the play in editor mode to new window. And then you can just hit play right on the toolbar here without having to keep moving the windows around and going back.
I should totally do that like all the time. Where's that hiding? Is
new
that
editor window.
New editor window.
Yep.
Oh my god, I'm so excited right now.
And so now you can just maximize the blueprint and hit the play button on the toolbar there.
I feel like I should have known that. There you go. Sweet. So after we draw that, we just do a really quick check. Did we hit anything, yay or nay? And then based off those results, we do a couple of quick little checks of math. We say, all right, what was the normal of what we hit? That's how we know what side, or basically what direction the wall was facing. We get that normal, and we multiply it by how far we want to jump. So there's kind of our jump magnitude right there, which that's hard-coded and something I had to play with to figure out a good number for. The other thing I had to figure out after a lot of testing was I had to kill out his existing velocity. The problem here is if he's falling down a really long chasm or something and you want him to jump off of a wall, if you don't do this, he's falling down the wall really, really fast, and you hit the button, he just bounces off the wall and continues falling at full speed. So you got to take his existing velocity and essentially zero it out so he can fall and then bounce back up, which I can demo real quick now with my cool little expanded window out here.
And that's something you could play around with, like if you wanted to get sort of an N plus sort of sliding down the wall, like where he can't quite fully do it, you could take away 80% of the velocity or something like that, so he's not 100% of it.
And I did play with it for a while. For me, I really loved the ability to just like get really close to the ground and be like, oh, nope, I want to go back up now.
That reminds me a lot of Strider.
Yeah.
Oh, yeah. I tried to play the remake of that and wasn't super
It was really hard.
enthused. Yeah. I'll have to give it another try. So anyway, we've got a little function here that launches the character. Really, that's just adding the velocity that we've solved from figuring out what direction the wall was facing, multiplying in our jump magnitude. Once we've got that, we set the controls rotation. This is literally just flipping the character. Because if you don't do this, if he's like facing to the left and he jumps, he'll still be facing to the left. This just flips him around so he's rotated in the right location. And then we play our jump animation when all that is said and done. So it looks pretty big, but it was actually a fairly easy setup at the end of the day. Now, I realize that there will probably be a lot of questions about how all this works and how to use it. Again, like third or fourth, fifth reminder, this is a project that we're going to be throwing up into the Learn tab so that you can play with it on your own and take it apart and ask questions. Just keep in mind that it's really like I guess not entirely polished. It was just something that I put together mostly for the fun of it, to figure out how some new systems work, and that's how I encourage you to go into it. Just use it as a way to kind of explore different things that you can do. Now, what I want to do before we jump into Q&A is show how we can expand upon this game. So I wanted to add a bad guy to the game. Now, in truth, the game is already set up to have bad guys. There's already some code inside, and I code loosely, right? There's some blueprint scripting in the game mode that allows us to spawn an enemy. So we have an enemy class slot. If that has any value whatsoever, if we have fed this any kind of a class, then we're going to fire off the spawn enemy timer. And all of this is essentially figuring out where the character is and setting up two theoretical spawn volumes, he said with fingers, so two spawn volumes on either side of the screen. And if it's on the right side, the characters will be moving left. If it's on the left, they'll be moving right. So they're always kind of moving in toward the center of the screen. So let's make a bad guy, just kind of for the fun of it off the top of our heads. Now, when I was doing a little bit of prep for this live stream, I realized that I needed a new sprite, and I didn't know if Photoshop was going to be on this machine. So I brought in a drawing of a potato. So I figured I would make a bad guy out of a potato, and it gets to reinforce a little bit of the Paper 2D workflow anyway. So let's start. We'll just right-click on this texture. It's just a PNG file, and we'll make this into a sprite. And we'll call this the potato sprite. I think I need better glasses. And there you go. We have the best sprite ever. So we should probably adjust a few things about it. Its source region, I'm sure, is fine because I'm not seeing any scraps or anything else hanging out inside the sprite itself. The collision is a little on the rudimentary side. So let's see here. We could probably fix that up. Let's just shrink wrap it. We'll just well, we'll kind of be lazy, but we will clear out some of these extra vertices which are floating. Now,
the shrink wrapping's been improved dramatically for 4.8. It won't be in 4.7, but it's coming.
Awesome. See, that's actually why Michael's here. It's more than just to sit here and judge me for using his tools the wrong way. It's also to feed us valuable information about what's coming on the horizon. Oh yeah. So and now if you are doing any sort of shrink wrapping and you see results like this, what it probably means is you had a bunch of random scraps in your alpha channel. So little bits of pixel data that are just kind of floating out in space. Now the good news is they're color coded, so the white vertices you probably don't need, probably.
And you could also just go into collision edit mode and then just click around the potato to add points to it as well.
I know, but I was hoping this would be faster. I was trying to, you know, cut corners.
I understand.
He said jovially. All right. So cool. Now our potato has the most excellent collision that he could possibly have. All right. So now we could, I mean, naturally, we could just bring this right into the world. We could take its, make sure its location set to 0. I mean, you don't necessarily have to have your game at 0, but it's pretty good practice, right? To make sure that when you're building your game, you have a common location in the y-axis, and 0 seems to make the most sense. That way, anything that needs to be in the background can have a negative y, and anything that needs to be in the foreground can have a positive y.
And that's another thing that we're going to improve for 4.8 as well. We're going to have basically a layer snap, so when you drag and drop something into the viewport, in 2D mode, it'll automatically snap to a particular plane, and you can pick which plane.
I'm so excited by that. Because like I've had to do this like a million times now. You drag something in and then like,
reset
its value. Yeah. Such to the point, actually, not to digress or get too sidetracked, but I have a blueprint here called level structure. It's basically how I built this level. Check it out. So you bring this in, and it's got a sprite, and it has a little tiny widget in the middle of it, and you just drag the widget out, and it creates a platform. And it rotates too, so it all just kind of works. But I realized like I was having to reposition all these guys, so in their construction script, they set their own Y translate
to 0. They just
force
themselves to the right plane. Yep.
Yeah, it made me very happy. Now, the problem with that is, of course, you can't really have this thing be anywhere other than Y of 0, but, you know.
You can make that a property.
I know. I just hadn't. Anyway, so let's see. Let's go back to the potato. So we got the potato, and then just for the fun of it, let's tell the potato simulate physics, and we'll play. Oh my God, raining potatoes. That just makes me so happy. Okay, awesome. So let's turn this into some kind of a bad guy. So to do that, though, first off, let's get rid of the sprite potatoes. Let's make a new blueprint. And we'll base it off actor, because it's really just going to be something that will live in the level. And we'll call this the potato. I can't see that far away. Potato enemy. I think that's right. I mean, if it's wrong, you guys are going to laugh at me later. It's fine. Now, this is going to need some stuff. So it's always asking for a scene root. Now, this is mostly one of my workflows. It has nothing to do with really anything else. I will tend to put a scene as my base root for just about everything.
Yeah, same here. And that way you can always adjust the pivot around and stuff like that.
Yeah, because if you don't do this, so the next thing, look, I'm just going to take my sprite and drag that right into the component list. But if I decide that I need to offset that at all, I've got to have that scene component in there in order to create those offsets. And we'll call this the potato or potato sprite. Awesome. Now, what I really want out of this, now, did anybody in the room play Castlevania?
Yeah, of course.
Good. Then I don't have to get any like crazy wisecracks about how old I am to remember that game. So Castlevania has these enemies called Medusa or Medusa heads or whatever, right? And they just wave up and down and come in and kill you. I'm the worst in the world at surviving Medusa heads. So let's make a character or an enemy that works kind of like a Medusa head. Now, Medusa head has two things that it does. It moves forward and it waves up and down. I'm totally going to cheat with the forward moving. We are going to go under our component list, and I'm just going to grab a projectile movement component. This is just going to give him a default, you will move forward by some amount behavior. And we'll set his initial speed to like 500, and we'll set his gravity scale to 0, because if you don't, you're going to have a really kind of sad enemy who just kind of plops to the ground. It's funny, but it's not useful.
More like a real-life potato.
More like a real-life potato. And the idea here is these are enemy potatoes, right? These have something to do.
They have magical powers.
Yeah, magic power potato. All right, so let me take my little play mode. Let's switch this over to simulate. And, oh, he's not moving. So a couple of things we should probably double check. One, make sure that he is probably at 0. And check again. And he's still not moving. So let's make sure a couple of things. First off, let's make sure that he probably doesn't need to collide with anything, because I think colliding actually causes issues sometimes. So we're going to tell him to overlap everything so we're aware of the fact that we're hitting stuff. Let's see, projectile movement should be on. And that all looks good. And he's still not moving. Why isn't he moving? I feel like he should be moving. Make this nice and big. All right. Well, that's just the darndest thing. Hang on, let me grab my other enemy. I'm cheating right now. So let me grab like the first guy I ever set up and see if there's anything really crazy different I did with this guy. So he's basically the same thing. So he has a projectile movement component. He does have a collision surface for his root. I don't think that should change anything though.
So go back to the projectile movement real quick.
Donk.
I guess that's the only two properties that were changed.
Xeno Twitch says, maybe doesn't peel like moving.
Oh,
terrible.
I'm loving
I'll
it.
show myself out. That's what he said.
Well, let's see. I'm sure I can figure this out. Whatever in the world's going on. Let me try just setting this as a collision surface instead of a scene component.
Well, just saying. So projectile movement has at the bottom. No, that's the right velocity, I would think.
Yeah, 500 should be about right. So let's see. The only key difference here is instead of a scene component, we're using a collision. So let's try that and see if that helps. So let's see. We're using a sphere. It doesn't necessarily even have to collide with anything. We'll just grab that. We'll make that the root.
Brain Shack asks if it's moving into the Y direction.
Is it? It shouldn't be.
I think at the bottom, a little bit further down, there's a velocity. So it should be moving in X.
Yeah, so by default, all projectiles move forward in X, which is one of the nice little things about Unreal. X is often considered the forward axis. And I leverage that fact an awful lot in my work. So let's see, let's try this again. And bump. There it goes. So it didn't like talking to the scene component, but it's fine with talking to this guy, which, that's fine, whatever.
No, we should file that though.
Yeah, we should totally file that. I'm looking at you. Yeah, we should.
I have nothing to do with the movement component.
Well, yeah, but you're here.
All right.
And you're a programmer. Somebody's got to catch hell. I mean, I guess I could catch the hell. That's fine. All right, so look, I'll increase the radius so we can kind of see this thing. So, all right, so we've got our initial movement, and that's good. We now have a potato that, when we simulate, just shows himself right off the screen, which is awesome. So let's give him some movie up and downy behavior, that's the technical term for it, obviously. So the way I'll do this is with a timeline. Now, we'll call this the wavy timeline. Now, this is also just kind of like a personal workflow. Whenever possible, I will often just make my timeline curves go between 0 and 1, and then I'll assign multipliers to them outside of the timeline. But your mileage may vary, and I get that. So I'll just drop in 3 random points, and let's just set their time and values individually. So time will be 0, value will be 0, and then let's do time of let's do maybe 0.5. We'll do half a second. We can always change this around later if we want to. And then didn't set the value. Got to do that. So we'll set the value to 1. And we'll just go ahead and adjust the view so we can see that. Let's grab our last one, and we'll set the time over to a second, and the value back to 0. Awesome sauce. And we'll grab all 3 of these guys and just set them over to user. So now we have a nice little waveform. Perfect. Use the last keyframe as the end of the animation. We can also go ahead and check autoplay and loop, so it'll just keep on doing its thing over and over. Okay, so awesome. Now let's take our, well, I guess we grab the whole thing, but let's grab the potato sprite, at least for starters, because we can base all of our collision off of him anyway. He's got his own collision. And we will add relative location. And let's just connect that to update.
Do you want to add or do you want to set?
Well, I think it depends on how we do this. So if I do, I guess you could probably go either way, right?
Mm-hmm.
Let me try. So you're adding 0. No, you probably do want to set, because if you don't, he's just gonna go up and
Yeah,
he'll
you
go up
might
again.
accumulate error.
Yeah. I love those too. Man, accumulate errors make my day. So let's do set relative, or so even, well, offset. I'll bet it's offset. Yep. So add local offset. Let me try that, see what that does. Now I'm going to do a little bit more cheating here. We're going to take his delta location. I'll drag a wire back off that and do make vector. What I'll probably have to do is change my curve now, and we'll just do it -1 to 1.
Okay.
And that'll solve the problem. Because I know what you're saying. In fact, I thought about fixing it, but I was like, why not just show it? So, oh, well, looks like that doesn't work for simulate. Oh, it's actually doing what I thought it would, but he was already kind of off the screen when it happened. So here, watch this. Oh, you see, he's going up really slowly, but he just keeps on going up. And that's kind of boring too. So first off, let's make it less boring. Let's take the number that comes out of this, and we will multiply it by another number. Let's say like 10. Or, well, I typed in 100. You want to try 100?
Sure. It's going to fly away.
I know, I love that though. All right, so plug that in, and then compile, and simulate, and see ya. He's gone, that's fine. Goodbye, potato. All right, so obviously that's a little much, so we'll do 10, and recompile, and then simulate. And there's your accumulation error. He's just going to keep getting higher and higher and higher, which, you know, maybe that's useful for somebody, not for me. So what I'll do is I'll jump back into my timeline, and we'll grab this first keyframe and set its value to -1, and take this last keyframe and do the same thing. Just set its value to -1. So now it's going to add and it's going to subtract, and that should, I would think, solve my problem. You can go away. We don't need you anymore. So now let's simulate. And, oh, there you go. It's just waving up and down, little crazy potato. Now, another thing to throw out there is that it's quite possible this potato is too big. I want to keep in mind that I just got to say that on a live stream. It's possible this potato is too big. And this allows me to bring up a really important property here inside the Paper 2D sprite editor, and that is your pixels per unit. So what this is literally a correlation between the number of pixels in the texture versus the number of units that represents in Unreal Space. So right now, 1.28 pixels is 1 unit. So if I double this and we do like 2.56, now it's 2.56 pixels is 1 unit, or he just really kind of shrunk down by 50% in both axes. So if we save that and then we test this again, look, I've already got a smaller potato, which is probably better for this game instead of having a gigantic, massive potato which swarms you and murders you. Okay, so that done. We've got our behavior in terms of motion. He moves forward, he waves up and down, and that's all well and good. But now we need to control what happens when the potato hits the player and what happens when we hit the potato with a fireball. So let's go ahead and get that behavior in place. Make our screen nice and big. We can probably scoot this back a little bit. So let's start with an overlap event. And let's see, if we scroll up to the top, we've got event actor begin overlap. So that means something just hit this actor. And we know what the other thing was that hit us, and that's super important. So let's check first to see if this potato hit the player. So we'll drag a wire out from the other actor, and we're going to perform a cast operation. Now, Michael, what is a cast operation?
Basically, is this thing I don't know about something I do know about? So like...
So you don't know what a cast is?
No.
Sorry, I had to.
Basically, it's asking, what are you?
Yeah.
So are you this? So in this case, we're asking, are you a character?
Yep.
And so once we know you're a character, we can do character-specific things on you.
Exactly. So it's just a way for us to kind of confirm what it is just hit us. In this case, we're saying, hey, that thing that just hit us, is it the character? Awesome. If it is the character, we want to call a function called damage. Now, there is an apply damage which comes along with the system. The character blueprint that I actually have my own damage function of my very own, and that calls the animation that causes him to look like he's hurt and all that kind of stuff. So we'll just call that, and that takes in a given damage amount. So we'll say he has a 100% damage. We'll say this takes 20% of his damage away. So cool. We now have the behavior for what should happen when it hits somebody. So let's give this a try. So we'll play. Oh, well, that's not right. We'll go back to doing it in a new editor window. And he's already flown away, so let's move this in a place that's kind of useful to us. There you go. That should give me time to prep. Get drawn into the game. Here it comes, and oh, it didn't hit me. Oh, there it goes. Well, okay, so that's understandable. I didn't actually mention this. When you first initialize the game, he's got about a 5-second window where he's invincible, because if you start the game off and you're like immediately mobbed by enemies, it makes the game kind of unplayable. So I had to work that in. So after that time expires, this is working just fine. Okay, so we've got what happens if we've overlapped the character. Now let's see. Let's make something happen if we overlap the fireball instead. So let's see here. If failed, so we'll just continue this chain. If whatever we hit was not in fact the character, let's instead check and see if it was the projectile. And that'll just be continue off of failed. So what you're literally saying is, hey, that thing I just hit, was it the character? Yes or no? Yes? Okay, do this. No? Okay, well, let's check and see, was it the projectile instead? Now, if it was the projectile, then we have a couple of things we want to do. The easy thing we want to do is just destroy this potato. So that's real easy. We can just drag a wire off here and say destroy actor, and that comes in with a reference to self. So that's pretty easy. So, and I'm so used to getting that out of the way, right? Once you establish a workflow, all right, come on, potato, boom, gone. Awesome. So that was easy, but it'd be nice if we also had kind of like a special effect of some sort. And it turns out I already made one, a really simple particle system that will kind of birth into life. So let's create that instead. So I'll cut this connection, and we will say spawn particle emitter, or spawn emitter. There we go. Spawn emitter at location. We're not going to attach it to anything. The problem with attaching it is its lifespan, or the lifespan of the emitter, will be bound to whatever it's attached to. And we want this to be kind of like a freestanding emitter. So what's its location? Well, that's easy. We know where this bad guy, this enemy potato, is because we can just ask it. We can say get actor location. And that will be the location where we want this emitter to be born. And auto destroy. So as soon as the emitter's done doing its job, it's just going to kill itself. We just need to feed this some sort of emitter, and I've got one in here called kill enemy. If you want to take a really quick look at that, it's hiding over in the content browser. So here's what it looks like. It just bumps out some really cheesy looking particles that look kind of like eraser shadings. So if we play now, here it comes, and boom, awesome.
People really wanted French fries. Just wanted to say that.
You know, and if I had my tablet here, and if I thought of that in advance, I totally would have done French fries. But it didn't occur to me.
Well, see, that's something to try out when you download this project.
That's right. That's right. First person to give me the best particle system of French fries. They at least get mentioned by somebody later, maybe. I don't know. Okay, so I guess we need to make these enemies now appear in the screen. Now, again, as I mentioned earlier, here in my game mode, I've got some blueprint graph code that allows me to spawn something. So again, all we're doing is saying, hey, did you ever set the enemy class? Because if you did, start up the spawn enemy timer, and all he's going to do is just spawn enemies from either side of the screen, and they're just going to move in toward the center. So the good news there is all we have to do is go over to defaults. We can take the enemy class, and what did we call it? We called it like potato something. So potato enemy, that looks perfect. We will spawn those guys. Spawn delay is 2 seconds. We'll see how that goes. We'll probably end up with a whole lot of potatoes. And let's play. Oh my god, they're already everywhere. We're being mobbed by potatoes.
That's awesome.
So, I mean, with that, we've taken a look at the next stage beyond the basics. Of course, the basics being what we covered in the intro to Paper 2D training videos, which are already on YouTube. So I guess now would be a pretty good time to open the door up for any questions. And we've got some that came in previously. Let's see, we've got how would I create a cable with physics using Paper 2D?
So I haven't played around with the cable component very much.
Me
but,
neither.
I suspect what you could do is you could probably use the cable component and then get the location and draw sprites along that. But what might actually be easier is using the terrain spline component, which would let you, get already a smooth cable going along it, but it doesn't do any physics on its own. So you'd be setting the points on that spline based on cable simulation that either you write yourself or maybe you could try and kit bash the cable component and spline component together.
Yeah. I mean, the old school way of simulating cables when you don't have a cable simulator lying around is you have some invisible rigid bodies that you just constrain together and just make sure they've got enough room to kind of dangle a little bit. And then when they get bumped by something, those are
swing back.
Yeah, they actually they don't do anything. They just move some other object. In this case, they'd be the points of your terrain spline. So you'd get that simulated motion. You got to keep in mind though that like that is a physics rig that lives under the hood, which is in turn driving something else. So performance becomes something to think about.
Yeah. Although if it's just a couple points, it's probably not going to be.
Yeah, it should be just fine.
But if you have like a field of ropes hanging down, that would be a
I had a game that was literally based around lots of hanging ropes, right? All right, so let's see. What is we got that one? Oh wait, yeah. What is a good method of having a paper 2D character with swappable equipment that will change the sprite to match? So I read this question earlier, and this is kind of a loaded one because it really depends on what your final look has to be like. If your look is very, I don't even want to say retro because not even retro did this, right? If it's just like you're just rotating the sprites, you can use socket on each sprite of a flipbook. So if you take, actually, I think I can show you. If we jump over to Unreal for just a moment, I'll just go to the potato, and if we open up his sprite, there is an area here where you can start adding sockets, and a socket is just an arbitrary location. So I now have a new socket called None, and I could, for example, I could have my character have a socket for every frame at the location of his hand with the proper position and rotation, and then attach, say, a gun to that, and then as I run, that gun is just going to update along with the socket. That's one way to do it. But that's also kind of a cheap-ish way to do it, depending on how you mean it, right? Because the answer to your question is how you do that is really dependent on your final look. Like, go play Contra for the NES. And then come back like 2 days from now when you're done playing it, because that game's awesome. But like, so that game doesn't just have a bunch of static guns. Like your character's doing a lot of this, and the arms move away from the camera, so the gun had to be like hand animated.
Yeah.
If you're doing something like that, then you've just got a whole lot of sprites to draw. And your equipment will probably just entail your actual character being broken up into a series of sub-sprites, and you just set whatever flipbook is going to represent whatever equipment they have set up at the time. So, you know, they have the bulletproof vest on instead of the t-shirt, you swap out for the flipbook which contains the character wearing the bulletproof vest. It means you have a huge library of sprites, but that's kind of how games used to do it back in the day.
Yep. And you can also do things where you can either like bake in all the permutations. So like, you know, if he's wearing this hat or if he's wearing this body piece, you know, you have to end up making, you know, all the combinations of hat and body piece. Or you can do things where like you've got the hat separate, and so you can swap out the hat sprite and it's still animated as it, you know, what people will commonly do is they'll like make a base body that's like sort of, you know, just not wearing any clothing at all, and that'll be animated, and then they'll paint on top of each one of the animation frames, so like the hat moves like this throughout each frame and things like that.
Right, and you'd have, I mean, I wouldn't necessarily redraw the entire character for every single piece of equipment because that's way too many permutations, but like if you break the character up into like a torso and some arms and some legs, then you can swap out the flipbooks associated with just that body part.
Yeah.
And hopefully everything would blend together really well. I mean,
and so that's two visual styles. Another thing that a lot of modern 2D games are doing now, we don't fully support it in the engine yet, is using something like Spine or Spriter, I think it's called, which are basically sort of 2D Maya, effectively. So they're skeletal animation tools that are designed around making 2D animation. So you can bake those out to flipbooks and then use them in the engine, but you can't import the hierarchical information into the engine right now. But that's definitely something we want to add in the future.
Well, the other thing too, I mean, you could, speaking of like Maya or whatever, you could just set up a scene in Maya with a fixed camera position that represented your sprite, and then, I mean, Maya's going to let you render out to a frame stack anyway. And nobody ever said you had to have a sprite sheet. You could, you could import a stack of textures instead, and those textures could just be your frame stack out of Maya. So, I mean, that would be a way to go about it.
Well, I mean, that's also the way like Tappy Chick was originally built. It wasn't with Maya, but the concept's basically the same. You can actually build a character for a 2D game as a 3D model if you wanted to, and actually use the skeletal animation system in that way. It's just then you would have to have like Max or Maya or Blender as an external package. You couldn't do it entirely in the editor, which is one of the benefits of Paper 2D.
So let's see, next question, sprite batching. When's it coming? What are the requirements? For example, I'm using pre-made Atlas using Texture Packer, using 2 textures for each sprite material with alpha and RGB. For ETC1 compression issues, will the engine batch together sprites using the same material?
So there's going to be a couple different kinds of sprite batching available. One kind is already going to be available in 4.7, which is tile maps. So basically a tile map is for like a regular grid. You want to say, you imagine old retro games where, everything is, cells on a grid. You can use it not just for that, you can use it for other things too. Like the cells don't have to be exactly the same size in our tile maps. So you can end up having textures that overlap to do isometric things and things like that. Those are automatically batched in 4.7. So if all the tiles in a tile set come from a single texture, it'll just be one draw call per layer. For all the other sorts of batching, it will probably come in 4.8. The plan is definitely to have something akin to the instance static mesh component, which you use for batching in 3D, where you can add individual instances to it and possibly like a selective number of instances in the level and say, convert this into a batch. I'd like to also have fully dynamic batching where, it just gathers things together and then batches those. The big problem there is if you have translucent rendering, you can't batch things together across different layers of depth, because then they wouldn't render correctly if you had, say, a 3D object in between, like a 2D layer above it and a 2D layer below it. You can't batch the layer above and the layer below together, because then they wouldn't render correctly with respect to that thing in the middle. So if we have automatic batching, it's likely it would only work on opaque and masked rendering. It wouldn't work on translucent rendering because the sort order could be messed up. But yeah, like I was saying, the plan right now is for that to come in 4.8, which I don't know the exact timeline on because we've sort of extended out 4.7 to make sure that we've got a nice, really stable release and everything. Yeah, the other aspect was, will it be able to batch things that have like multiple textures and stuff like that? The way it'll work is anything that has the same set of textures in each slot and the same material can be batched together. So, if you've got a pair of textures that are related together, like, this is the base color and this is the normal color, or this is the RGB and this is the alpha channel, as long as each sprite that you're rendering has the same texture in both places and is using the same material, those will be able to be batched together.
Awesome. Next question is there a way to render paper sprites and not and other things like particles over UMG, i.e. having a UMG widget, which images or sprites? If not, is it coming?
So you can render UMG widgets in the world using the widget component, and once they're in the world, then you can have sprites or other 3D objects or whatever on top or behind
Interact with them.
In terms of actually rendering a sprite into UMG, like actually as a slate piece of content, that would probably be possible to do, but you might lose material support in exchange for it. So we could potentially do it where it just renders using the standard slate batching. But then you would just get, color times alpha. You wouldn't be able to do custom materials on it. Yeah. So that's something that would be possible, but I don't think it's currently planned.
All right, so the next one is sprites using custom textures. Right now I'm using a workaround using special material which encapsulates an alpha texture. When we'll be able to use more than one texture per sprite, at least a separate alpha mask?
So that will probably also come in 4.8. That is planned already. The way it's going to work is there's a node in your material that has like sprite texture. So what will happen is that node will gain a number, and so you'll be able to say sprite texture for slot 0, sprite texture for slot 1, and so forth, and be able to define those additional textures. And then in the sprite editor, like if you want to switch back to the monitor here. So where you see source texture, there'll be something like the base source texture, and then there'll be an array of additional source textures, and those will just go into slot 1, 2, or 3.
And you'll have access to be able to switch slots, like which one you're listening to?
Yeah, so basically what'll happen is in the material, you'll drop down like, here's my sampler for texture 0, and here's my sampler for texture 1, or whatever.
Okay, yeah, that makes sense.
And so that way, if you're doing Android, which is I think what Draydoc was specifically asking about,
right,
is ETC1 can't compress alpha channels, and so what you end up doing in order to have compressed textures is to put your RGB in one texture and your alpha in another texture, which seems like it would take up more space, but because it's compressed, it ends up actually being better than just using a single uncompressed texture.
Gotcha.
But also if you want to do special effects, like say, this is another harkening back to the material or the equipment question. Imagine you've got, say, a hat that your character can wear. One really cheap way to get variations on it is to do color masking. So you can say, I have a hat texture, but then I also have a mask texture that says this is material 1 and this is material 2. And then in a shader, you could actually, make the bulk of the hat yellow and then the badge of the hat red or whatever, and then have those colors mean different things. So like this is the fire hat, this is the ice hat, and so forth.
Or like Joseph's cloak from Castlevania Symphony of the Night.
Oh yeah, and actually have the
get that
the rainbow sort of
reference.
thing.
Yeah, then good
Yep.
for you. So let's see. The next one is I know how to adjust frame rates with Paper 2D sprites. However, I was wondering what frame rates you guys use for your sprites. I think most of the stuff I've done has been like 15 frames a second, honestly, for little more reason than I just don't want to draw that many sprites.
So with this, I mean, it's really up to the stylistic choices of the game. I mean, if you actually go back and look at sort of the NES or SNES area games, it's frequently something like 4 frames a second, just because there was not very much memory on those cartridges.
Yeah.
You can go up to, 15 frames a second is sort of a good middle ground, and you can easily double or triple frames so that you're not paying, the cost of a unique frame every single frame, only where you need it. But you can also go even higher. I mean, so I think it's Elysium or Dust and Elysium Tale or something like that. There was a Xbox Live indie game that was just really beautiful and it had really smooth, fluid animation. And I think a lot of their stuff was authored at 30 hertz. The one thing you run into when you're using straight flipbook animation is it can just get really big, both in terms of it takes a long time to draw each frame out, as well as it just takes a lot of memory to store. Like if you have high resolution sprites for a high frame rate, it can end up using a lot of texture memory.
Yeah.
But it's absolutely up to you. Especially if you have smaller sprites, like you can have small sprites that run at 30 or 60 frames a second and look really gorgeous and fluid. It's just you're also going to have to author those sprites and store them.
Mm-hmm. And which kind of ties into the next question was, would it be practical to create a run cycle in Flash at 30 or 60 frames per second and use that to create a sprite? I mean, it would. You just have to realize there's performance trade-offs with having to have that much texture memory in use.
Mm-hmm.
Another question was, how can I change the opacity of a sprite at runtime? That usually just ties into the material that you're using.
So there's 2 different ways. You can create a material instance dynamic and adjust a parameter in the sprite that goes into the shader. But you can also use the sprite color on the sprite itself. So every sprite instance has a color associated with it, and that's just sent down to the material. And so the default translucent material just multiplies that by RGB and by A. And so if you scale that value, that A value in the color instance, that will make it translucent or not translucent. But you remember, there's 2 different kinds of materials. There's masked translucency, where it's binary, like it's a cutout, so like it's completely opaque, and then there's the area around it that's completely translucent. And then there's translucent, where it can be sort of smooth gradient, where it's like if you imagine a sheet of glass or something, it might be 50% translucent, where you can see the blue texture from the glass itself, but then you can also see through it. So if you've got the sprite set to a masked material, then adjusting alpha won't do anything until it falls below a threshold, and then the whole thing will disappear. So you make sure you're using a translucent material.
And that's under the default material inside the sprite editor itself.
Yeah.
So some questions came in on Twitch. Any hope for an SVG import of textures? And what about support for normals and lighting? The normals and lighting bit is already there.
Yeah.
That's a question of what default material you're using. So by default, if you've just been creating sprites and dropping them in, their default material is masked unlit sprite material. Mm-hmm. If you take a look, actually, if you jump back over to the editor for just a moment, if we go over to the content browser and go to view options and show the plugin content, which includes the Paper 2D folder, inside of this, you'll find there are some lit materials as well. So if you swap out and use one of the lit versions of the materials, then you have access to lighting and materials, and you can start doing some really cool things. I played with those early on, but then when I was first doing my initial demo content, it was just too much to digest for a lot of folks, so I just hadn't got around to throwing that in yet. But you can do some really neat things, particularly with normal maps if you're going for a higher level of visual quality in your 2D game, because you can actually move like a dynamic light through, and of course the normal maps will update with all their lighting.
Yep.
What about SVG import of textures?
So SVG import is something we've talked about before. I actually had a look around trying to find an import library that was under a suitable license so we could actually integrate into the engine. and didn't really see anything that was, sort of self-contained. So if you guys know of one, feel free to send it in. But if we were to import it, we would actually still rasterize it on import. So like you would give it a width and a height, and it would rasterize and come in as a texture. So it's really not that different from exporting to a PNG or something from Inkscape or whatever program you're authoring SVG in. We wouldn't actually keep it and treat it as vector art, for rendering purposes. If that makes sense.
Any hope for destructible sprites?
That's not something that we have planned right now. The destructible system that we have in the engine is sort of heavily tied into physics and 3D meshes. So while it could be possible, it would be a decent amount of work. I mean, there's a couple different possibilities if you want to do something like that. You could pre-fracture your sprite, like basically bring in a single texture, and then in the sprite editor you can quickly create a bunch of sprites from a single texture using the edit source region mode, and basically make overlapping sprites where you've got like separate render geometry and collision geometry where you've got it fractured up.
Sure.
And then whenever you determine that the sprite has taken enough damage, then you replace the one whole sprite with the list of the prefactured sprites, and then let those go off and fall down or whatever you want to do.
Yeah, like I mean, off the top of my head, the first thing I would do is pre-fracture it, then make a blueprint that was the fractured version, and then all that is just the individual sprites pretty much lined up like they would be if the thing hadn't fractured yet.
Well, what you could do is you could just set the custom pivot on them so that the pivots of all the different fractured ones are at the same location.
Right.
So if you spawned all of them together, they would end up being at the correct location within the fracture.
And then like the swap would just be swap the sprite out for that blueprint and then go, and they would just fall or blow apart or whatever they're supposed to do.
And if that's something that you wanted to build a game around, that kind of concept, it wouldn't be that hard to extend the sprite editor tool to sort of have a fracture button that throws some split planes down or something on those lines. But it wouldn't be the same as the fracture tools in like the Physics Studio or whatever. And getting those to work on the 2D content might be challenging.
Gotcha. That makes sense. The next one was, can you set 3D backgrounds or 3D boss battles with Paper 2D system and 2D characters just like Disney Hercules on PS1? I don't think I ever played Disney Hercules on PS1, but I see what you're getting at. And
so like turn on engine content and show like putting a sphere or something in the background.
Yeah, I mean, there's really no rule that says you have to just stay 2D. So like if I, Michael was saying, if I go over to the engine content, let's just search for sphere because there's got to be something in here. I mean, I can totally, that was a material I think I just dropped in there. So here we go. Bink. Now, I have no lighting in my level, so, I mean, I would need to put in some kind of a light.
Or you could throw an unlit material on the...
Yeah, I mean, there's options, right? There's ways to get around this problem. But yeah, there's nothing actually saying that you are limited to just using a two-dimensional scene or 2D assets in any way. You can add in whatever you want.
And so what you probably end up doing is, instead of using an orthographic camera where everything is completely flat and there's no perspective or parallax, you'd end up switching to a perspective camera with a really tight FOV. And so that way you would be able to see, like, as you pan around, you see the 3D object, moving more or less in relation to how far into the scene it is.
Yep.
But you can freely mix and match Paper 2D and 3D meshes in Unreal.
Here we go. So now if I play... Where is that? Is it this way? Yeah, okay, cool. So there's my little 3D sphere. Now, if that had collision on it and everything, I could actually collide with it. I could
jump on top
it.
of it.
I could jump on top of it. Yeah, if it was a physics object and I had set up my fireballs appropriately, I could punch it around the scene, all that kind of thing.
Yep.
Is there any way to change the capsule component to a box for old school 2D game? When the character's in the corner of the platform, he's stuck, even with a special change to the bottom of the capsule in character 2D. Basically, I guess when you're making a character, just swap out that capsule for a box.
Well, the problem is the character movement component relies on that
Based
capsule.
heavily on that capsule,
Yes.
right.
I know that's something that Zach has talked about changing in the future to allow it to work with a box. Zach Milton,
There's
who's
a lot of
sort of a
Zachs
character movement expert. He's talked about wanting to support like a box collision, sort of for a more classic 2D game, but I don't know what the status on that is right now. I would just suggest opening a forum thread or opening a answer hub question.
Let's see. Could you have just used the Z override to cancel out velocity for wall jumping? Quite probably, I think. I mean, that's just That's so blueprinting is just like coding, right? There's like 20 ways to solve every problem. Can you add multiple sprites like a Flash game? What about 2D IK?
Yeah, you can add as many sprites as you want. For the 2D IK, you would have to implement it yourself, but there's absolutely nothing stopping you from implementing it. Like if you want to, have a, I guess what they mean by multiple sprites for Flash game is something like, the body parts, like
Sure.
you have the arm is separate from the, so it's a
Torso,
sprite
separate from
that's,
the head.
sitting on top of the upper arm and stuff like that. And so what you could do is basically set those up in a hierarchy in your blueprint, and then have it so that you figure out the angles of the joints based on where you want that arm to reach to do the IK. That's also yet another reason why I'd really like us to get to the point where we can use the existing Anim Blueprint system to do 2D animations, because that'll allow us to reuse all of the skeletal controls and everything else that we've already got for 3D animations when we're working in 2D.
Gotcha. Let's see, with multiple sprites, do we have a sort order, or do you just have to offset them? I only ever offset them.
So there's a sort order override that you can use. So this is only used for translucent objects. If you're using opaque or masked, offsetting is the only way, because they're rendered into the Z buffer. They have to actually be at separate physical offsets. But if you have translucent objects, you can use the sort order to say, I don't care what their offset is, I always want this to be in front, or I always want this to be behind. And it's, I think it's translucent sort priority, or translucent sort key. It's one of those two properties on the component itself for the sprite. Another thing coming in 4.7 is a explicit 2D sort mode. So the default way of sorting translucent objects in Unreal is to sort based on the distance to the camera. So if you have a sphere here, even if say imagine you have like a little small square in front of a really big plane. If it's only a little bit in front of the plane, because of the way the Unreal sorting works right now, this could actually end up being sorted behind it, because the sphere here, if it's off to the distance versus the plane's origin is here, the distance will be shorter than that distance. And so that doesn't do what you want for 2D, but it does what you want for 3D. So like if you have hair or particle systems or stuff like that, the way Unreal works by default is the right way. But if you've got 2D meshes or like little flat pieces near each other, then we've got a different sort method which will sort just based on the distance into the y-axis, ignoring the distance along the line. So it's sort of the projected distance along that axis. So that's in the renderer settings in 4.7.
Gotcha.
So that'll help out. But you can use the sort key as a hammer. It's on top of everything else. It's even on top of that new sort mode. So it always wins.
Makes sense. I just got so used to actually physically moving them around, because
Yeah.
technically that's how you work, like in Photoshop, or whatever.
Right.
Like you move to front, move to back. It's the same thing.
Yeah, 'cause that's one thing that's kind of important to point out. It's both a benefit and a curse, but Paper 2D really is no different than anything else in 3D. Paper 2D renders through the same pipeline as other 3D objects in Unreal. It's just a quick and easy way to make and position these things.
Yeah.
So that means both on the plus side, it seamlessly mixes and matches with actual 3D objects, but on the downside, it also means that you've got the same sort of issues with the Z buffer and translucency sorting as you would if you were really working in 3D versus a 2D engine where it's like, I render them in this order, and that's exactly how they stack together.
Well, it's interesting. So before we did this live stream, there was, of course, the forum post about it, and somebody, it wasn't really a question, it was mostly a comment, said it would be cool if they did more of like the JRPG style of sprite game instead of the standard platformer like we've been tending to do. And the thing there is, that really has very little to do with the Paper 2D aspect of it. You just need a lot more sprites for what way your character's facing and maybe which way he moves or what weapons he's using. But other than that, the real heavy lifting for that is in the code for your game. Whether you're coding it or blueprinting it, like how are you moving? You're still going to have a big vertical plane, which will be your world, and you're just going to move the character in one of 8 directions and interact.
You won't have gravity, so you probably wouldn't use a character movement component. You do custom movement, but otherwise the logic would be fairly similar.
Right, but the point is like the heavy lifting of that is outside of the world of Paper 2D. It's really all about how you set up the game itself.
Yeah. But having said that, that is an example game I'd love for us to have, especially once we have like the ability system online. I think that'll be really neat to have like an RPG example, probably both a 3D RPG and a 2D sort of top-down retro kind of RPG.
A link to the past.
Well, that's an action RPG, but
I know, but it's probably the best one. So
It is great.
anyway, so let's see. Are these sprite animations using only static preset flipbooks, or can I bring in whole sprite sheets and designate which frames to use in an animation like I do with Unity 2D? Well, I mean, you can bring in your sprite sheet, and then you have to create the. I mean, if you pre-make the flipbook, like if you just grab all of the sprites and drag them into a flipbook, it's just going to grab whatever you drag. So once you've got your sprite sheet cut out into a whole bunch of individual sprites, you have control over which sprites make it into the flipbook and which ones don't.
Yep. So
if you grab only sprites 6 through 9, those become, your flipbook.
yeah, so like a flipbook asset doesn't actually store the texture data itself. It just stores references to existing sprites. And so you can have the same frame being used in more than one flipbook at a time, or you can split it up across a bunch of flipbooks. So you imagine you've got, say like a 3-frame idle animation and a 10-frame walk animation or something. But like the 7th frame of the walk animation also looks good as a hit impact animation. Well, you could use that in your hit impact animation as well. And so, yeah, you can do whatever you want in terms of breaking up, coming from a sprite sheet to making individual flipbooks from that sprite sheet.
Yep. So we've got, how do you do a one-way jump-through platform like Contra? For now, I try some ways to begin overlap on my platform. Change character collision to off and then try to tick on. So basically, like, when you're playing Contra, you can jump up onto a platform and you can't fall through.
I'd probably create a custom collision channel so that all the platforms that you can jump through are, say, jumpable platform is the collision channel as opposed to world static. And so what would happen is whenever you're in your character blueprint, you would change what the collision of the character capsule is so that it's, when you're standing, when you're not jumping, or when you're falling, you would block against that channel. But then when you're jumping up, when your velocity is going up, then you would overlap with that channel. And so basically what would happen is, whenever you're moving upward, you'd be able to pass through them, but then as soon as you start moving downward, you'd no longer be able to pass through them.
Yep.
You might run into some issues if you're like currently interpenetrating with one when you sort of reach the apex of your jump and you start falling. But that's the kind of thing you could play around with overlap initial or whatever it is.
I think that's right.
Yeah, there's a flag like that where you can say, I only care about this if I start overlapping. I don't care about it if I was already overlapping when I started.
Right.
But I think that would probably be the most robust way of handling it. And then the only thing you have to do is in your character movement component or your character blueprint, either in tick or when you start jumping or start falling on those events, you flip which collision profile that your capsule's using.
All right, we've only got time for a couple more, I think. Let's see. We've got. Can we do a material like the software Sprite Lamp does? It's a soft. It's a soft that creates 4 map for lighting up, down, left, right to create fake lit sprite for each direction of the light.
Yeah, I'm not familiar with that
I
software.
have no idea.
I know there's been there've been a number of packages that come out in the past year or two that will take like a single 2D sprite and then generate like a normal map or a height map from that sprite. And so anything like that can generate a normal map, you could just bring into the engine and use directly.
Yeah.
You could also hand paint one. Like I can't think of the name of it, but there was this one cool 2D game that had like sort of a isometric view of a dungeon, and it had all hand-painted sprites where like he would paint a little pixel art skeleton, and then he would go in and then he just made a sphere of pixel normals basically, and then he would use that to like paint like the left edge is this color and the right edge is this color based on if I'm painting the left side of the skeleton, I use the left side of the normal sphere to paint, and then I get the correct normals.
Right. So let's see. Is it possible to switch camera movement from side scroll to front view like Crash Bandicoot? I mean, the answer is yes, because you still have a 3D scene, so you can move the camera however you want to. It's just a question of what you do with your sprites at that point.
Mm-hmm.
I'm pretty sure Crash Bandicoot was a 3D game.
Yeah, it was.
Yeah, so it's easier to do that in a 3D environment. When you have actual 2D sprites and you move, if you shift the view, you're going to get those parallax
the sprites,
issues.
you'll start to be able to see them
Yeah,
like their
you
cards.
start to see them edge on, and then you got a problem. So if you're keeping that kind of thing in mind, you can do whatever you want to with the camera.
Yeah, so I mean, you could definitely do something where like your sprites are like here, 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 here. Like so they actually curve a little bit as you go, and then have a camera that curves around it. But that kind of thing, the more you try and be 3D, the more you maybe should be using 3D.
Yeah, and now I have done a couple of really cool trials, like with the R-type style of shooter, where you can take the camera and tilt it slightly. So instead of things panning perfectly from left to right, there's just a little bit of receding into the distance.
Yeah.
And that looks pretty nice, but you don't want to really adjust that angle by too much, or you start to kind of squash in your sprites and see that they're actually, flat planes, and you have a problem. Let's see, real quick, let's try to wrap the last of these up, and I think we're done. Why the pixel per unit on sprite is not 1 by default? That's easy, because textures need to be powers of 2 when they come into Unreal, so we're kind of making that assumption that you're probably working with something like 128 pixels by 128 pixels, and we have to convert that over to the decimal grid.
Yep. And so there's absolutely nothing stopping you from just setting the pixels per unit to 1. There's actually a project setting under Project Settings Paper 2D that is the default for newly created assets. So you can set that to 1 if you want. You can set it to 1.28 or 2.56 or whatever. But it's just making it so that, like, imagine you brought in a full-size texture and made a sprite out of that and dropped it into the level. Now what's going to happen is all of our grid snap settings are decimals. They're powers of 10. And so this thing would be, 25.6 units wide or whatever if it was 226 texture. And so that's not going to snap nicely to the grid. And so this is just a way of scaling it.
Yep.
But you can make that value whatever you want.
Right. Let's see. There's instant sprite components in the engine or in BP?
Not yet.
Yeah.
So an instant sprite component is going to come probably in 4.8. You can effectively make one now in C++. So the way that like a sprite component communicates with the render thread is through fsprite batch. I believe that's the name of it. And that's basically just a set of vertices that it wants to render. And so it collects the data on the game thread and then sends that over to the render thread and it's rendered. But like a default sprite component will just take the vertices for a single sprite and send that across. But there's nothing stopping you from in C++ saying, I want to collect a bunch of different sprites, make them into this array, and then send that whole thing across. And so you could manually batch in C++ already.
Gotcha. What's the story on tile maps? I saw the note about it in the 4.3 documentation.
So tile maps are like I was saying earlier, they're basically a set of layers where each layer is a grid of cells that can either be occupied or not occupied via a tile from a tile set. So there was a very, very early prototype in 4.3 that didn't really work very well, and so it was marked as experimental. Your mileage may vary, we may change the data types and data structures and stuff. And it didn't really get much love until 4.7, where it's gotten a lot of effort to make it much more robust, to get the tools and everything to the point where it can do the sorts of things you want. You can import from tiled, it supports different projection modes, all those sorts of things. I didn't take off the experimental tag in 4.7 simply because it doesn't handle collision right now. So if you wanted to do collision, you'd have to do it manually for your game. So like, if I'm moving a character left, you'd have to say like, okay, where is the character in the tile map? Let me sample the cell. Is that occupied or not? And that's how, old retro 2D games were made anyway. They didn't have PhysX or something on a Super Nintendo. But I'd absolutely want to get to the point where, you can go into the tile set editor and say, for this tile, it's a 45-degree ramp, so make the collision for the 45-degree ramp. And then it automatically generate the collision like that. But that hasn't happened yet for 4.7. So tile maps are effectively out of experimental in 4.7 in terms of the data structures are stable. We're not going to change things like that. But they don't have collision yet, and so since they may not meet all of the things that somebody would think of when they thought of the word tile map, that's why they're still marked as experimental.
Gotcha. Well, that looks like all the questions, and it's certainly all of the time that we had for today. So, Sean, did you want to sign off? You want to just handle this? Because I saw how you handled the intro.
I got it. I'm sorry.
All right. No, it's all good.
So if we didn't answer your question, please feel free to submit that in Answer Hub. That's answers.unrealengine.com. And Zach, we really appreciate that you joined us. You're messing this up for me. Thanks for the potato. It was great. Next time it needs a cape, though.
You got it. You got it.
That's pretty much it. Thanks, Michael, for joining us, too.
Yep. Pleasure. Have a great day, everybody.
Thanks, guys.
Bye, guys.